Okay, this video is about limits at infinity. So on your worksheet that I have for you to do, there are a few problems that you already know how to do because I covered that when we did 2.2. So I'm not going to be going through 32 through 40 at the bottom of your sheet because you already know how to do those. I am going to be going through the ones on the left side because we haven't looked at when x is approaching infinity or negative infinity. What do you do with those? This is really kind of cool because at this point you get to see vertical asymptotes and horizontal asymptotes. You have learned sort of the how to figure out where they are. People have taught you. You look for where on a rational function where the denominator is going to be 0. Either you'll have a whole or a vertical asymptote there, and you know that's how you find them. But now we get to see the definition of that and also a horizontal asymptote. And so it's kind of cool. Horizontal asymptotes are defined to be this. Given a constant k, the line y equals to k is a horizontal asymptote or a horizontal line that the function approaches for a function v if as x increases without bound, or in other words, as x goes to infinity, the function approaches this constant value k. As x gets very, very big, as x goes to infinity, the function horizontals out like this. So this, I'm looking at a horizontal asymptote right here of some sort. So that's the behavior of the function. You've seen these in rational functions before. Vertical asymptotes is, we've already looked at those, as you take the limit as x approaches a number, either from the left or the right. If it goes to positive or negative infinity, you're looking at a vertical asymptote. So we have this picture here, and we have these problems here. So let's just have a look at this. The limit as x goes to -5. Oh, I think I drew this wrong. Let me make sure. Oh, sure enough, I did. I drew my graph wrong. So let me fix this. This is not, I didn't draw it at the right place. The limit as x goes to -5 from the left and the right. So let me fix my graph. I had it at the wrong. This is -4, and this is -5. It's supposed to go here. So from the left, it's supposed to go right, down like that. And then on the right, it's supposed to be like close to here, doing this. Okay. So this is -5, and this is -4. Okay. So now I'm okay. The limit as x goes to -5 from the left, from this side of -5, our function is going down to negative infinity. Negative infinity is the answer. This fact alone, that's all I need right there. That's enough to say there's a vertical asymptote there at, down here where x is equal to -5. That fact alone is enough to do it. If I didn't have that, but I did have this, the limit as x goes to -5 from the right is shooting up to positive infinity. That fact alone is enough for me to write the same vertical asymptote right there. How about, let's look at this. The limit as x goes to 4 from the left. As we approach 4 from the left, it's going down to negative infinity. Negative infinity right there. Okay. So we can write right there, x is equal to 4 is a vertical asymptote. Let me see what else that said. Are there any horizontal asymptotes? There are. I see one right here. Do you see how it leveled off right there? As x is going to negative infinity, y is going to 1. It's approaching the value 1. So we could write it like this. The limit as x goes to negative infinity of g of x is equal to 1. Because of this, we could say y equals to 1. It's a horizontal asymptote. Likewise, right here, it's leveled off in a horizontal fashion. At what value? At -2. So we could say the limit as x goes to, as it gets bigger and bigger and bigger, positive infinity, the limit as x goes to positive infinity of g of x is equal to -2. This statement right here, when x goes to positive infinity or negative infinity, if it approaches a single value, we could say y is -2. These are horizontal asymptotes. Okay, so that's the graph part. Now let's look at these problems here at the bottom. What if you don't have a picture and you just have a limit you have to evaluate as x goes to infinity? What can you do about that? What can you say about that? Well, this is the technique that you can use when you have a rational function like this. If it's a rational function, you can divide the numerator and the denominator by the highest power of x that you see, and then that makes it easier to evaluate, see what's happening. So let's do that. Let's look at number 16 and say, what's the highest power of x that we see? And the highest power I see is x cubed. So I'm going to do this. I'm going to go here and I'm going to divide the numerator by x cubed, 1 over x cubed, x squared over x cubed over x cubed, x over x cubed, 1 over x cubed. If I divide the numerator and the denominator by x cubed, it will go into each term, and this is legal because we've divided it by 1. But as x goes to infinity, as x is dividing by something bigger and bigger and bigger, just like when we were dividing by something smaller and smaller and smaller, the value got bigger. When we take a number 1 and we divide it by 10, it's 0.1. Divided by something bigger, 100, it's 0.01. By 1,000, it's 0.00001. And if we get divided by something bigger and bigger and bigger, that quotient becomes smaller and smaller and smaller. So 1 divided by something like infinity is going to go to the value 0. Right here, even though x squared is not a 1, see how x cubed is a bigger value? X squared divided by x cubed is really like, we could simplify this into 1 over x. So 1 divided by infinity is still going to go to 0. X cubed divided by x cubed is the number, this is like a 1. But x divided by x cubed is going to 0. 1 divided by x cubed is going to 0. So basically we have a 0 minus 0 over a 1 minus 0 plus a 0. Or a 0 over 1, which is 0. That's what that limit equals to. So let's look at 18. What's the highest power that we see? We see x cubed. And so this should make you think of how you learn to find horizontal asymptotes. The rule is if the degree of the numerator and the denominator are the same, you take the ratio of the leading coefficients. This is where that rule came from. Take the numerator and the denominator and divide it by the highest power of x that you see, which is, again, x cubed. So this is going to be the limit as x goes to infinity, negative infinity, of 4x cubed over x cubed plus 6x squared over x cubed minus 2 over x cubed all over 2x cubed over x cubed minus 4x over x cubed plus 5 over x cubed. What's going to happen here? 2 over x cubed, that's going to 0. 6x squared over x cubed, this is going to 0. X cubed over x cubed is a 1. So basically we have 4 plus 0 minus 0, or a 4 in the numerator. In the denominator, 5 over x cubed, going to 0. 4x over x cubed, going to 0. X cubed over x cubed is 1. So basically we have a 2 minus 0 plus 0, or a 2. The ratio of the leading coefficients is 2, and that's the limit of this function. The limit as x goes to negative infinity of this function is 2. So y equals to 2 is a horizontal asymptote. All right, right here, let's look at this one. What do you do when you have a square root? What's the highest power? Well, if you take the square root of x squared, it's an x. So the highest power that I see here is an x squared. So let's do this. Let's divide the numerator, x squared over by x squared, and the denominator by x squared. So when I divide this by x squared, if I put it underneath a square root, x squared is going to become x to the 4th. So this is like x to the 4th, 1 over x to the 4th. So what we have here is, this is a 1 in the numerator, right? X squared over x squared. And this is a 0, and this is a 0. So basically we're trying to divide by 0. And so this does not exist. This does not exist. It's going to infinity, or we'll say it's going to infinity. 1 divided by 0, it doesn't, it's going to be, it's going to, it's going to positive infinity is what this is doing right there. So the limit, you can't get the number out. Okay, let's look at this one. I'm just going to tell you how to do it. This would be the easiest way to do it. Well, I'll just go ahead and do it. This is a t to the 1, and this is times the square root of t. If you think of this in fraction powers, the square root is t to the 1/2. 1/2 right here. All right. But when you multiply powers to bases, you can combine the numerators through addition. So 1 plus 1/2 is 3/2. So I could write this as t to the 3 over 2. What is the highest power of x or t that I see here? It's 3/2. It's bigger than 1. So let's do the same thing. Let's go through and divide the numerator and the denominator by the highest power of t that we see, which is t to the 3/2. So let's have a look at that and see what happens. All right, the limit as t goes to infinity of t to the 1 over t to the 3/2 minus t to the 3/2 over t to the 3/2 all over 2t to the 3/2 over t to the 3/2 plus 3t over t to the 3/2 minus 5 over t to the 3/2. Okay, if t is going to some very large number, this is going to 0. 3/2 is bigger than 1. This is going to 0. This is canceling. This is just going to be a 2 right here. So we have 2 plus 0 minus 0. We have a 2 in the denominator. In the numerator, t divided by t to the 3/2, this is going to 0. 3/2 over 3/2 is a 1. We have a -1 in the numerator. So the limit right there is -1/2. Here's the last one. Let's look up here. The limit as x goes to negative infinity, okay, of 1 plus 4x to the 6 over 2x cubed. The highest power of x that I see is x cubed. If I think of it under a square root, the square root of x squared is x, so the square root of x to the 6th is x cubed. So x cubed is the highest power that I see. So let's see, the limit as x goes to negative infinity of the square root of 1 divided by x to the 6th plus 4x to the 6th over x to the 6th. That's what x cubed looks like when it goes underneath the square root, over 2 over x cubed minus x cubed over x cubed. Let's see what's happening here. 1 over a very big number, whether it's positive or negative, is going to 0. This is going to 0. 2 over a very big number is going to 0. So let's think about this. X to the 6 over x to the 6, this is a 1. So basically we're looking at the square root of 0 plus 4, the square root of 4. Down here we have 0 minus 1. All right? So what we have here is the square root of 4 is a 2 over -1. -2 is what that limit goes to right there. All right, so that's limits and infinity, section 2.6.